In a previous video, we'd had a look at a traumatic moment being encoded by the amygdala and the different kinds of information that may be present at the time. So let's just remind ourselves of that. So here's the bank robbery, and within that there's different types of information. There's the threat itself, and it's the gun in this case. Sometimes threat stimulus can be innate, an unconditioned threat stimulus. In other words, we've not had to learn to be afraid of it. So heights would be an example of an unconditioned threat stimulus. Or enclosed spaces. We are naturally afraid of being trapped in enclosed spaces. But in this case, it's a gun. We've had to learn to be afraid of a gun, so we call it a learned threat stimulus. Either way, it is the fear-producing content. It's the threat stimulus itself, learned in this case. Okay, beyond that, we've got other information. It's closely related, but not fear-producing in itself. We call it complex content. And in this example, it's a piece of clothing that the gunman is wearing. It could just as easily have been the smell of their aftershave or the smell of the sweat, or it could have been the sound of their voice. These are bits of information closely related to the threat coming at us, but it's not the threat in its own right, so we call it complex content. We've also got the wider surroundings, which we call context. In this case, it could be the particular look of the surroundings, the particular kinds of furniture. It could have been the music playing in the background. It could have been the smell of the furniture polish. You know, it's things about the environment that's present at the time where the traumatic event is occurring. Now, all of this ends up going into the amygdala, but all goes in slightly differently. It's important for us to be aware that all of this information does go into the amygdala, because we need to sometimes be acting as detectives when we're helping people. Obviously, we can understand why someone might be afraid of a gun, but it may be more of a puzzle to the individual as to why they have a strong emotional response to something like the smell of furniture polish, or seeing a particular kind of clothing, or it may be a particular piece of music plays. So as detectives, we can understand that there's a lot more encoded in a traumatic moment by the amygdala than just the obvious threat stimulus. What we've got here is a diagram that shows a microscopic look at the amygdala. Within the amygdala, there are what we call subnuclei, specialist clusters of neurons that play particular functions. There are at least 13 of these, and as Haveners, we want to be aware of 5 of these in particular, and these are the 5 we'd like you to be aware of. You can see that these 5 specialist clusters of neurons, these 5 subnuclei of the amygdala, have letters labelling them. And at the bottom of the slide you can see that the name that goes with the letters is there just to helpfully remind you. So the top left, that cluster, is called the lateral nucleus or lateral amygdala. Below that, the green one there, the accessory basal, AB, accessory basal nucleus. In the middle, the blue one, B, that stands for basolateral nucleus or basolateral amygdala. Top right, we've got the central nucleus, and below that, the basomedial nucleus. Each playing a specialist function, and we're going to look at that in a little more detail. In relation to threatening content, complex content, and context. As a very brief overview, just looking at this slide, the two on the left, the lateral amygdala and the accessory basal nuclei, they're the receivers of threatening information. Information about a threat stimulus. That's where that information enters the amygdala. In the middle, the basolateral, That's all very much about storage of that threatening information, but also everything else. So it also stores the complex content and the contextual information to help it spot in the future any sign that there might be something threatening like that happening again. On the right hand side, the central nucleus and the basomedial, they're kind of outflow. In other words, they're sending messages to the rest of the brain and nervous system and all over different areas of the body to get ready to respond. Whether it be fight, flight, freeze or defensive rage, to get us out of a fix. Survival responses. And of course we know those can be overdone beyond the threatening event itself, such that people have phobias and panic attacks and responses that are no longer helpful to them. And so for us to be able to change the way the amygdala works is going to be a great gift. Let's have a little bit of a closer look now at specific aspects. So what this slide shows is that the threatening content itself, in this case learned, the gun, it comes in via our senses and something called transduction occurs. That is, it's converted from our information hitting our senses into an electrochemical signal. And that electrochemical signal gets sent to a part of the brain called the thalamus. And the thalamus is like a sorting office. Where do we need to send this information next? Well, because it's threatening, we send it to the amygdala. In particular, I'd mentioned that the lateral amygdala was one of the areas where threatening information lands. So in this case, seeing, hearing, a gun would just go to the thalamus and then directed to the lateral amygdala. There is an exception to information that's threatening hitting our senses, and that is the sense of smell. It's thought because smell is often our earliest warning system. If we think of prehistoric times, primitive times where we're out there hunting and avoiding predators and surviving in a natural environment, if you think about the sense of smell, it would often allow us to detect danger earlier than things we would see or hear. We could maybe smell signs of a predator if the wind's in the right direction before we'd ever see or hear that predator. Equally, something like fire. We could perhaps smell that fire from the smoke being carried by the wind before we would see or hear it. So because it's such a great early warning system, such a primal sense, if you like, protecting us, it has a very direct route to the amygdala. Any smells that are threatening. And it lands in this very specialist area called the accessory basal that's lit up there in green. And that will then feed through to the lateral amygdala, where all the other sensory information about a threat lands. So they are connected, but olfactory information doesn't have to go through the thalamus as before, it just goes direct into the accessory basal. Very direct route. This next slide is showing what happens to the complex content, the clothing worn by the bank robber, the smell of the aftershave, the particular tonality or accent of the voice, for example. That too goes to the sorting office, the thalamus, after it's been transduced into an electrochemical signal. From the sorting office, it gets sent to the cortex for further evaluation before being sent to the amygdala to be stored and processed. It sends it to the basolateral area of the amygdala. This is where non-threatening information lands that's closely related to that threatening event that's unfolding. So we might need this information. We'd better store this information. It's not a threat in itself, but it might give us clues in future that danger's around and we're ready to respond really quickly. So it's stored via this basolateral specialist nucleus in the amygdala. So whereas the threatening content would land in the LA or the AB if it was smell, the complex content goes via the thalamus to the cortex and then to the basolateral amygdala, just to be stored to protect the system in the future. Clues that there could be a threat present. The wider context also gets stored. So again, going to the thalamus from our senses, being transduced into electrochemical signal, it goes to the thalamus, the sorting office that is, then to the cortex, then to the hippocampus, another specialist area of the brain that's very much involved in memory storage, and then lands in the basolateral amygdala. Again, the basolateral is playing an important storage function. We better store the context as well as the complex content and the threat stimulus. Let's store it all, because these could be clues that will help protect us in the future. Then you'll see on the right-hand side, we've got this outflow. We've got the central nucleus, which is all about sending messages to other areas of the brain and the body saying, let's get ready for flight, fight, or freeze. And a specialist area called the basomedial, just below that, is responsible for a particular kind of outflow called rage to be triggered, defensive rage. Now sometimes people say, well, what's the difference between fight and defensive rage? Well, if you were to think about, say, two deer that are battling with one another, antlers locked, very often what's happening is they'll size each other up first, they'll walk up and down, sizing each other up. There may be a burst of activity, fighting, and then they'll back off. They'll be sizing each other up again, and then maybe some more engagement, and so on. There may be a bit of flight as well, where one runs off for a while, they come back, they size each other, they engage in more fight. It's all quite structured. Whereas defensive rage is instead more like an explosive response. It's like where every ounce of energy is exploded into one moment. It's where, say, if a rat was cornered, it's tried running away, but it's got stuck in a corner, and now there's a predator coming at it. An explosive moment where it just leaps at the incoming predator. You know, it's quite remarkable when you can see a cornered animal really go into defensive rage. It's like a last-ditch attempt, everything thrown into it. You know, you can see animals really bristle up. You can see them become larger than they really are just because of the way that everything bristles. And they can really put a huge amount of energy into one last-ditch attempt. But also you might see this in humans. Not only as a last-ditch attempt, they've tried fighting and flighting and got trapped, and it's a last superhuman attempt to frighten off the perpetrator. Sometimes it can be the first thing that's triggered. So a mother might be meek and mild in their personality most of the time, but seeing their child threatened, suddenly you see them find some superhuman strength that just explodes out of them, most out of character, and they just really explode at the perpetrator or the situation. It's the kind of thing that would have a little old man or a little old lady being able to rip open a car door to save their grandchild if there's no one else around. Really explosive amount of strength and energy in one moment. Anyway, those outflow areas responsible for those survival behaviors and responses are the central nucleus, fight, flight and freeze, and the basomedial, which is more that explosive rage response. So it's a nice summary slide, this. You can see we've got on the left hand side the incoming threatening information. We've got storage of everything about the event in that middle section, the basolateral nucleus, the blue one. And then we've got outflow from the nucleus to prepare us for survival responses in the central nucleus and the basomedial. I think for a Havening practitioner, one of the most important things here is that the basolateral nucleus stores everything about the encoding moment. Everything that's hitting the senses, the obvious stuff and the less obvious stuff, is all stored and can all potentially trigger the alarm system, the amygdala, into fight, flight, freeze or rage in the future. So that's why we need this detective work. Equally, just to point out to you that we've talked about potentiation of neurons with AMPA receptors. That all happens in the lateral amygdala. These AMPA receptors come to the surface in much greater number, and it's like we've put lots of extra detectors in an alarm system, if you like it, covering a particular room. You know, it's like, let's extra protect this room by putting loads and loads and loads of detectors up so we'll spot any danger very easily. Pretty much that's what the lateral amygdala is doing. It's like, for a scenario like this, let's have lots of AMPA receptors up on the surface, primed and ready to respond if anything like this ever happens again, as well as helping them deal with that particular moment that's unfolding. So actually it's the lateral amygdala that we're targeting with Havening. When we do Havening, we're looking to get depotentiation of those AMPA receptors, in other words, permanently removing those AMPA receptors. So it's the equivalent of us cutting the wires on all those detectors that may be overprotecting a room more than we need anymore. So we're taking those out. We're taking those AMPA receptors off the surface now. We're reassuring the amygdala we don't need them anymore. That's what Havening does. We don't need all those AMPA receptors anymore. We can still have the information stored. We still know what happened, but we don't need to kickstart a fight, flight, freeze or rage response anymore. Okay, let's have a look at the next slide. This is a lovely summary slide, just shown in a slightly different way by Louise McKay, a fellow Havening trainer. So you can see there we've got the lateral amygdala shown top left as the alarm system. That's where all the AMPA receptors are potentiated at the surface. You can see at the bottom left we've got a picture of a nose there. It's just reminding us that the accessory basal is detecting the smells of threats. We've got the basolateral in the amygdala, all about storage. We've got the filing cabinet there, look. And then the top right, we've got action, ready for fight, flight or freeze. And then a particular kind of action just below that in the basomedial. If we need defensive rage, this particular cluster of neurons, the basomedial nucleus, will trigger defensive rage. Just a little more on the outflow. The outflow has different components to it. So when survival responses are triggered, there's emotional aspects to that. We have emotional feelings. It could be anger, it could be fear. Some of the most noticeable ones in a traumatic event unfolding. Then we've got autonomic. That is responses that are generated by the autonomic nervous system, things that happen on autopilot, like our increased heart rate, increased breathing rate, sweating, muscle tension, just getting absolutely ready for action. Autonomic, automatic responses. Then we've got some thoughts and perceptions and interpretations, thinking. We call that the cognitive aspects to the outflow. I recognize this. Oh my gosh, this is dangerous. This means I could die. These are the kinds of things that we'd put within cognitive. Somatosensory is bodily feelings. Soma is body. So things that we're sensing in the body. Pain, tingling, numbness, feeling off balance. Those kinds of things are somatosensory aspects to this outflow. Now, if we put them in the order of cognitive, autonomic, somatosensory and emotional, we've got an acronym there, CASE, C-A-S-E, CASE. That can help you remember those 4 components to a traumatic moment: cognitive, autonomic, somatosensory and emotional. They all get encoded in that moment as well. They're part of the outflow, getting us ready for survival. They're also encoded, stored as part of that information, ready to protect us in the future. So I hope that this is useful to you, and do look at the other videos. Watch this as many times as is useful for you to remind yourself. And that's it from me on this video. Bye for now.